Equinor? My company?
Yeah, our company.
Why? Like,
Some protests.
ah, that's weird.
Yeah, at a university. Plus, you're going to be talking about all sorts of stuff.
Yeah.
Cool. I think we'll get started, just in the interest of time. They're going to turn off the lights. So I'm really excited to introduce Swapan Sahoo, who is currently at Equinor in Houston. Swapan and I have been working together for the last year and a half. We met after a talk I gave, and we've been thinking about some questions about deep time and what gets expressed in sedimentary rocks. And that's where Swapan started. So in 2014, he got a PhD from the University of Las Vegas, where he worked on things like oxygenation after the Maranoan glaciation. At that point, he moved to Houston, and he started in the petroleum industry, first at BP, then at Equinor. And what's really impressive about him is that what he's managed to do is maintain a research program while being in industry. He's advised multiple students. This is something that is traditional. Is traditional. This is something that petroleum geologists have done in the past as well. And so today he'll be talking a bit about his science, but also just about this path that he took to get here. So with that, I'm going to hand it over to Swapan.
You guys hear me okay? Yeah. So first of all, I think first I should thank Akshay to invite me and meeting some of the undergrads and grads throughout the day and some of the faculties. It's an honor for me. But I also want to say, this talk is not really representing Equinor or my company in whatsoever, right? So that is okay. And like Akshay said, it's more like a journey and more like, I will say, an inspiration rather to some of the next generation that I have gone through or I have struggled or I have faced. It's been almost 21 years I am in US. So obviously I have seen good days, bad days. So I will walk you through the journey. At the same time, I never lost the passion why I came here. And so maybe it will be, take it as an inspiration, take it as a science, take it as a whatever you want. But so with that, first few things is where do I actually come from, right? So in 2004, when I mentioned I came here 2004, there was no power from the village that I was born. But today I work in an energy transition, all these mega things. So no power to power, like energy, whatever. But then, I first went to Tulane in 2004. And in 2005, one of the worst hurricanes ever. I lost practically everything. I had a passport, my laptop, a pair of jeans, and a flip-flop. We went to Texas A&M because we slept on some friends' cousins' floor. Then we saw our house get flooded and all of that stuff. It's not easy, I'm saying today. It's been 20-something years, but it was 2005, August 1st. And for some reason in my life, 1st is not a good day. 13th is a great day, right? So personally, I got married on Friday the 13th, 2013. So good luck, right? So that journey kind of pushed me I was in the airport in Houston because we thought a bus will come from Tulane to all our friends who were locked into the Superdome. I still remember that day vividly because Indian government didn't let us take a flight. And every Italy, France, they were like, yes, hop on the flight, show your passport, go home. I didn't. And me and my roommate, we drove back to College Station. And I was thinking that, what do I do now? How do I manage my life? I left everything, came here. But then Texas A&M gave me an offer that, you should just do a PhD in oceanography, just change what you want to do. I said no. And people were like, are you nuts? Are you an idiot? Because you have nothing there in Tulane. You are giving a full funded PhD. You should take it. I said, well, then doesn't mean just because they're offering me, I will take it. So my brother was in Chicago at the time, and then I moved to Chicago. And every university in the US opened their doors. Everybody got affected. You can come here, study the semester. So I moved there for 1 semester. So that's my Chicago. Then in 2006, I actually went to Northwestern for a few years. It was not the glorified journey, not today, discussion, some other day. Then from there, I went to UNLV, one of the coldest place on the US to like warmest place on the US. And life changed because I had a project, I had a lot of stuff, very, very difficult 5 years that it changed, and I restarted my PhD at UNLV. I still remember in the plane, somebody asked me, so you're moving from one of the best universities to a casino? Is there even a university? I felt very sad, and then, like, what am I doing? It's been like 2009, January 13th again. And then the second day, my advisor, Gang Ching, some of you know him, one of the best, carbonate stratigraphy I have seen personally, and he's like a sharp one. He can, like, we are just getting off a car, for example, he's already in the mountains and smoking a cigarette. He was a chain smoker, but a brilliant geologist. And he told me the second day that you are here now, forget about the previous 5 years. So what do you want to be? I said, I want to be in faculty. So he pushed me into my idea the second day that from UNLV, you have to do a very good work. You have to think about publishing in Nature or Science. I'm like, this is second day. What are you telling me? What are you asking me? And then, but that virus he put in my head to push me, to do something good. So that's the journey began. And then after 5 years, almost like I had a very good PhD I worked a lot with in the University of Riverside, California, like University of California, Riverside, and with Tim Lyons and a bunch of other groups, and met beautiful people on the way. Ariel Anbody in ASU, with Brian Kendall, and all these people were like my colleagues, collaborators, whatever. But then in 2013, the person I wanted to marry, her dad was asking, like, what do you do? And this question, what do you do, still haunts me, right? So I said, well, I'm planning to write a proposal to get a postdoc. He doesn't even understand what a PhD means. I'm trying to explain him a postdoc. So then there was this job fair in Laramie, Wyoming. I went there, and so I got a job in 5 days in British Petroleum. It's not actually called British Petroleum. Right now it's just called BP, but they have been changing from Beyond Petroleum, British Petroleum, doesn't matter, it's BP. I took it because it was 6 times the salary I was getting at UNLV. Did I make a mistake? Maybe. But I was writing postdoc proposals with Simon Polton for Marie Curie in astrobiology, very, very academic. In the name of getting married and getting funded and getting salary, I just changed my career. All I thought was that, okay, rather than doing a 2 years of postdoc, might as well do 2 years of industry. It will give me an industry experience. Totally wrong, right? But if you look at my academic career, I had nothing until 2012. When will I do anything? Because I've been hopping from one university to the other. So the first paper I wrote was in Nature. It was like, what do I do now? But I tried to be very academic, very good work. But then I left academia in a way. I joined the industry. Nothing I can do from BP. Even a small APG presentation, I had to get a lawyer's approval, right? In a small, because if the logo is right or not, that is what they're really concerned about. Very challenging. And in 2017, I will come to all of these stories, but in 2017, I tried to get back into research with one of my really good friends. He inspired me a lot. But then at the same time, the current company, it used to be called Statoil, they changed the name to Equinor in 2018. It was the same job that I was doing in BP, but I knew they had an R&D department, research in Trondheim, Norway, because it's a Norwegian company. It just fully does, because they have to give back the people money. How did they do that? They fund, they pay for research. Then I slowly got back into different I was a Proterozoic guy in a way, but I started to get into different time periods because now we have different source rocks, which is the main bread and butter for oil and or gas, and then we start to look into these time periods and do different research. Be that PETM, be that Devonian Carboniferous boundary, Jurassic, Cretaceous, you name it. So I started to get involved into this, but that was not my job. I was hired for something else. Now, like I said, this question really haunts me. Like, what do I actually do? And guess who asked me this question quite often? My wife, right? So, and then I asked myself, like, what do I actually do? And I was joking with some of the students in the lunch, and people say, I work for an E&P company. E&P is exploration and production, right? We do for exploration. I have been mostly working in the exploration, like almost 90%, but not really production. But you know what the real E&P means in the industry? Excel and PowerPoint, right? So all we do day by day is bunch of data, Excel, and make a PowerPoint. So I can make a PowerPoint, like, hey, we have a meeting in 1 hour, put something together. I can make a PowerPoint. It's called PowerPoint engineering. I'm another PhD in that. So it's like really a talent, and most of the people are good at it because they can do what they can do in very short period of time and put something together to tell a story. So that's what I actually do. But in reality, I was hired for this thing called Petroleum Systems Analyst. And in BP, they used to call PEST. That means actually the word PEST. And the meaning was that if a seismologist or a geophysicist takes 3 years to grab data, process it, then exploration people like do the mapping like 1 year, then sedimentologists take 3 months, we get 3 weeks, and we, after like 3 years, 5 years of the project, we often kill it. And we are called the pest because we kill them, right? Because when I say kill them, because my job was like what's the probability or what is my chance of success that how much oil can be there in this prospect. So all the work has to be done from sand, from pressure, from sand quality, porosity, permeability, traps, fractures, overburden. All of that data comes together. I have to integrate it and make it a model to say this is my chance of probability for finding oil. It's very, very not too hard, but it's a very high risk because your word says or saves $150 million per well. So one well costs one. So stakes are very high, right? It's not that I will say something, if I fail, I will lose my job. But when the times are bad, you can lose your job. So the stakes are very high. That's my day job. But then what do I actually do? I do this modeling, get all this data, how much oil can migrate. But you see, one thing is that you are actually integrating all your knowledge from source rock, which we call for black shales, for example, stratigraphy, sedimentology, tectonics, salt overburden, salt movement, faults, fractures, everything comes together. I don't want to show too much about it, but there's a whole, workflow of models that we have to do every day to predict how much oil is there. But that kind of I was doing as my day job for almost like 2018, 2019. But parallelly, this is something probably happened in my life which changed how I have started to do things. And I named it Brief History with North Dakota. Because we had a asset called Bakken. Lots of oil has been produced there. But so far, I think Bakken has one of the greatest publicly available data, geological data, for students to work on. It's open. And slowly, the more and more I got to know, because I joined Equinor, I find my way, how could I access this data? Like I had a very good idea for four locations. When I joined Equinor, I started to realize there is 75 wells with 34,000 data. Now you are into something, right? So this change really happened to me in 2017, 2018, that I started to reinvent myself that I can come back into research, right? And so the other thing that I feel myself, like why I am here or why I have become who I am now is when I think about academics, when I was in a PhD student or something, all I used to think is that we will get a very good paper, right? But now, if I think about from business, all business does is, or when I say business, say a corporate, be that political agenda or corporate agenda, everything is driven by the commodity price or somebody's personal agenda. So we as a researchers can have to stop work any day. Like, so for example, we had a deep sea exploration, deep sea minerals. One day we just stopped it. So what does that all that research go? Nowhere. Somebody's desktop, somebody's hard drive in our corporate lockdown box. That's a loss, right? So I started to realize that the more you give out to students or contract with students, at least the data will be out. People will get to know like what has been done. And the more and more publicly data is available, somebody will do something with it, right? But so for me, it's like if I can combine these two, I can actually do high-profile papers, come back to research, but at the same time, utilize industry-level data, don't have to be driven by commodity price, but still do quality work. That, to me, is a satisfaction, right? I get both of it. So kind of like bridging the gap between industry and academia. So the other motivation is, that's not me. No, that's not me. But that's how energy transition, now we are, 2020, energy transition was not a buzzword. Digitalization was the buzzword. Everything has to be digitized. Unstructured data, structured data. There was like a buzzword. You guys in, Silicon Valley, like, Microsoft, and everything has to be structured. Azure platform, AWS platform, oh my God. But now it's this energy transition, right? To me, what is energy transition? To some people, it is like a light bulb. Can I have a light bulb at least? Like I can see things. But for us, I have right now, I have 3 cell phones. Like one is for office, one is for home, and something, another one I have somehow. Do I need 3 cell phones? I don't need 3 cell phones. People average have office laptop, house laptop, a tablet. Why do we need? So that means we need more energy. But the other motivation for me for the last 5-7 years was my really good friend Jeff. He sent me this picture, is that, hey buddy, look at it. I'm like, wow. So do I want to be these people who want to push the well back? Maybe they want to migrate to the land like evolution. Or do I want to be this small little guy to the bottom right and nobody cares about me? I'm like silently doing my work and I can actually evolve to something do good, right? Honestly, that has been a really good motivation for me. But I'm in this industry of what? Energy. That means there is pollution. There is this carbon, blah, blah, blah. We all know this story. There's nothing new to it. So if this is the case, if you ask me, what should I do? If I'm not tagging myself with or anybody, doesn't matter. I need to go to anywhere and plant trees. But will there be a carbon credit if you plant trees? Will they give you 2 cents per tree you plant? No. But if you create an industrial carbon capture mechanism that you inject the carbon somewhere, like some fancy science, then you get credit, right? But that is probably the fundamentals of saving the planet, plant trees. So what is a plant tree in a way? What does tree does? It takes CO2 and water and creates organic material and oxygen. Isn't that the fundamental that the world has moved on for last 4 billion years, right? So why cannot we do that in a simple way? But this particular concept has been my fundamental research as well. I have been trying to track oxygen since my PhD from 4 billion years or I'm still doing some banana formation, some early Proterozoic work, not only snowball earth, but tracking this oxygen story for the last 3 billion, 4 billion. So, but one of the byproduct of this equation is organic carbon burial. So 1 mole of organic carbon burial is 1 mole of oxygen released, right? So, so what's an organic carbon burial? Isn't that the same? That's the black shale. So we are living in this industry of energy, of oil, because end of the day, my phone, my laptop, the speaker, your seat, your jacket has something to do with the byproducts of oil industry. It's a sad thing, but it is what it is. We are paying all of this because of oil industry. I took a flight once from Vegas to Chicago to see my brother. One lady next to me is like, what do you do? I'm like, oh, I work for, and she's like, like this feeling of like, you work for oil industry. I'm like, lady, we are in a plane. Why do you think this plane is taking off with? Solar panels? Not yet, right? We're not there yet. Maybe in 50 years, but not today. So it is inevitable some things that we need this demand, but doesn't mean we have to waste it, right? So, but end of the day, black shales are the bread and butter for whatever we are doing. So in Earth's history, there's repeated events of black shales. You can call it OAE, but that has been my thing. And then my PhD, I have looked into these records of critical elements. Now we call critical elements. At the time, we used to call, redox-sensitive elements or trace elements. Now it's a fancy word of critical elements or whatever. But that was my thing, right? I try to do many things with that. But when it comes to the industry, fundamentally, it's the same black shales, but different time period that producing oil. So why cannot I look into trace metals and have a different story to tell them? So I try to push the industry that fine. I want to show much pictures about it because some things are confidential. But say, there's a thing called sweet oil or sour oil. Sweet oil means, or actually sour oil means you have a lot of sulfur, nickel, vanadium in the oil. So you have to refine it. That means more carbon footprint. If you have sweet oil, you don't have vanadium, you don't have sulfur, you don't have trace metals. It's a clean, nice oil. That means imagine, I can tell you, almost $1 billion per year will be saved from all the oil is produced in this country, only US. That means how much carbon footprint is that? So I try to push the research to the company, fine, we have to produce oil, but can we produce oil from the shales which actually has low vanadium, low nickel, low sulfur? We'll call it a sweet oil. So see how the research is suddenly moved from what I looked into my PhD as high vanadium, high moly, high sulfur. I switched it to low vanadium, low moly, so I can find a better oil, but a better carbon footprint, right? So, I slowly moved into like these ideas of global basins because we have been looking into global basins for screening. Where should we go? Where should we find oil? But to me, where can I find better, basins with better quality of source rocks? That was like, pivotal of my research during 2018, 2017. So now let's move on to this one of the basins which is in the US. These are the main producing basins in the US, and most of them are Devonian actually. Like US literally lives on Devonian source rocks. And one of the nice things is that, this was when I was looking at it in somebody's thesis, that, all these shales like Antrim, Chattanooga, Duvernay, they're all hovering around this Devonian Carboniferous boundary. And Devonian Carboniferous boundary is already a mass extinction, we know, Fresnian, Feminian, DC boundary, a little bit of glaciation. So all of this come together into a nice story. And the two major events like a Hengenberg and Kalhauser event. So I started to look into the Bakken because I had all this data. Now, to all the students or the next generation, having data, I don't think it's a problem. Right now, you can ask on LinkedIn, hey guys, I want data on this. I guarantee you, somebody will help you. Or reach out to me, I will help you. But finding the right question is the problem, right? What do you want to do? What do you want to do with that data? If you have a good question, seriously, there is data for it. So anyway, I don't want to get carried away. But I can skip few things. But Devonian Carboniferous boundary is very fascinating because I have been tracking sulfur isotopes. I love sulfur isotopes. There was this big shift in sulfur, and there was also ideas that I'm just skipping this that the main present day oxygen level actually changed in the late Devonian or DC boundary. So there is a market change in oxygen rise. Now, if we have these major black shales deposited during the DC boundary, all these basins in the Laurentia alone. So we also have these ideas is that is the DC boundary a trigger or the driver for all this carbon shift and organic carbon burial at the same time oxygen release? Because remember, 1 mole of organic carbon will be 1 mole of oxygen release. So the major shift in oxygen was probably because of this Laurentia dependent organic carbon burial. Something was driving it, right? We'll come back to the later that I'm working with Akshay actually. So that said, I started to build this story on this late Devonian 2 black shales, and initially, I had this 1 core or 4 cores rather, and what I was noticing is that coming from trace metals, I could see a zone that is like low vanadium and then high moly. That doesn't happen. Now, 20 years, people have been putting money into this basin. All they say, there is a 1 big chunk of black shale. I started to see 3 big chunks of black shale. And then, what magic happened was because if you think about these 3 zones, and we had this biostrat paper come out in 2019, people have realized that this lower part is the annulata extinction, the middle part is the Dashberg extinction, the last part is the Hagenberg extinction. So there are biotic crisis and there is a mass extinction event. How do I tie this story together? It actually helped me because before people thought this is only 1 event, 1 black shale. Because if I show you a picture of it, any average person will say, this is 1 unit. Where do you see 3 units here? This is 1 unit, this is 1 unit. This is a lower black shale, this is upper, this is in Mississippian, this is in Devonian. That's the boundary somewhere over here, the middle Bakken. So this was the initiation of these ideas that maybe there is 3 events and the 3 mass extinctions are related to 3 different events. Because, now this is a really complicated slide, particularly at this time of the day, so I'm going to simplify it, right? So you don't have to go to the dots. But you could see that the trace metals, particularly moly, vanadium, or zinc, or rhenium, they have these step changes on each level. So all this time, I don't want to go back to make you dizzy, all this time when we see at a black shale, the metals go really high and they decline because you get exhausted. The ocean uptake all the metals. Why do I see consecutively rise in metals? If seawater is the ultimate source of metals, inventory-wise, if I'm seeing higher and higher metals, the fundamental simple idea should be sea level is rising. Or the basin has access to more and more metals in each of these times. And they are statistically when I say statistically, I'm talking about 11,000 data points here. But so this is a 1D. I consider it as a 1D, like 1 core. But now, let's look at a 2D. I use like 17 drill cores with I think it was like 24 something hundred data points on this panel from east to west on the basin. Now you start to see, particularly for vanadium, you see there is no vanadium. And then the top part, which is the Hagenberg equivalent, is the most amount of vanadium, the most amount of moly. And you could see when you are actually, you see the whole basin is pretty big, but the last part is quite thin. Lower part is, this is the only part of the basin. That's the second part of the basin. That's the maximum flooding. So each time the basin floods, you get more and more metals because you have more and more access to the ocean. This is 2D. How about we look at this in a 3D? Right? So in the beginning, you have a small little puddle maybe a small little depot center. You have just water, maybe because it's not fully flooded. You have anhydrites and red beds on the coast because we see that. And then all the metals are pretty low. And then you flood a little bit more. Right? This is the Dashberg time, the second time that the basin gets flooded. Once you get this flooded, you could start to see that towards the coastal regions, you have a way more metals sequestrated than in the depot center. So now we are talking about all these modern mass extinctions and everything. Definitely the coastal areas is going to be more affected because a small little hypsographic change 1 degree change of sea level rise can actually create a lot of metal sequestration and make it anoxic or toxic. Right? So initially our paper was titled, eustacy, eugenia, and extinction. But we couldn't put a comma in a paper, so that's why we had to change the title. So anyway, the next third level is you see how the basin got fully flooded and there's so much metals got sequestrated. That's the Hengenberg extinction. And if you look at on the right-hand side, I have been, putting all this statistically data. So 1, 2, and 3, right? So each time the median value of this data for moly or vanadium, you see it's rising and rising. So this was the story that sea level rise can create mass extinction. So now you go to the industry. Think about industry. They have been this idea for all these generations that black shales are only deposited in a confined, restricted basin. It's not the case, right? It's about the nutrients and the flux of the structure, how the basin is designed, or what kind of productivity was happening. We are not talking about some small, organic material. Present day, it's 10 to 15% organic carbon value. And this is very much matured oil coming out. So originally probably was 20% by volume organic matter deposited. That's a bucket load of organic carbon, right? It's huge. So take it to a little farther. A few antidotes maybe is that I've been working with a few other people on different ideas. But let's ask this thing. We have this DC boundary and we have this carbon isotope. We have almost the same size, same thing in Chattanooga or New Albany or Sunbury or Woodford Lower, Woodford Higher, you name it. Everywhere we have these two, even in Vietnam, there's these two black shales. So one is before the mass extinction or before a glaciation, one is after the glaciation. Let me ask you this. If I pull down, today we want to cool the planet. So if I take all this CO2 from the planet and put it into black shales, what will happen? We'll cool down the planet. We could even create a glaciation. So this is exactly what happened after the lower one leads to a glaciation. 3 to 5 million years later, same basins, almost same footprint, same amount of TOC. Why didn't that lead to a glaciation? But it delayed another 20, 30 million years until the late Mississippian or Carboniferous glaciation. Why? So that's a question we are trying to solve by using lithium isotope. Some people got too crazy about reverse weathering a few years ago, and we were trying to see maybe there's a case that one is the carbon being reshuffled. It's not pulling from the CO2 that we think about, but the lower one does. But that's a project we have been waiting to get data for this time period to see what happens. The other thing is, I like trendology, right? I'm a trendology guy. So if I look at lithium, if nowadays everyone wants to talk about lithium, I will talk about it too. But if I look at moly and lithium, they kind of look very similar, right? I mean, my poor man's correlation. A low is low, getting high, little bit low, good enough. If I cross-plot it, maybe not, but in general, good enough. So if I have a model of actual data on the top, like actual gridded, not model, it's just gridded empirical data, then I could have a fit-for-purpose lithium concentration in the basin. But it's not the same everywhere we see. They also have a detrital flux coming and things like that. So maybe some other day, but I'm saying these are the ideas that we are chasing today. The other thing is I want to work with somebody, which I'm finding good people to work, one of them getting advice from Akshay. This is the resolution of trace metals that we have. This is what? 25 feet, right? And I have 600 or something data points in there. That's the resolution I'm talking about, 1 inch that we have. And now I started to put the last 400,000 years of sea level change. And I'm like, it looks weirdly similar, because the question is, another question is that how long were these events in Earth's history? 100,000? 200,000? Can we actually sustain an anoxic event for 5 million, like in the older times, or a Proterozoic? But in the Phanerozoic, can we actually, or is it like really short-lived, 50,000 years or 100,000 years? How do we calibrate that? So once we have this, when we have this really high-resolution metal data, we are trying to do astrochronological models. We actually got funded from Belgium. Another professor wrote a big proposal on doing astrochronology with all this data. So 2 PhDs will be working on this. So it's exciting. Now, I try to model a poor man's version, simple calculations. My model kind of looked like the sea level curve. So I'm very excited to see what it actually happens when we finish this project. Okay, now data. Sometimes it's a curse, right? It's just too much data is sometimes really hard to understand. But maybe not. So one day, me being stuck in COVID at home, I bought a big widescreen monitor like he has. It's great. It's just really you see things. And I had this map. I just color-coded the different types of source rock. Again, this is a free public data by USGS, around 5,000 organic carbon data available to everybody. You can download it in one click. I plotted with the different types because I calculated the different types. I went to the bathroom and I came back. I'm like, why do I see something which is a different color, looks like a fan? And I pointed out to you. These green dots looks like a fan that I work in the Gulf of Mexico most of the time. I look into sands coming in as a reservoir. Why do I look at sands? I'm like, okay, interesting. So if I plot that in a 3D space, how does that look like? Right? I just rotated the basin in a 3D, did some vertical acceleration. I'm like, that's cool. But if that's happening in the Devonian time, maybe or should be happening in the Mississippian, maybe we could see something. So I just, kept the same polygons and did the same thing for Mississippian. So there is a same pattern, a little bit off, has to be, but I just kept the polygon to make the story. But how could that happen unless there is a really, really big river bringing sediments to you, right? Now, that's where Akshay and I started collaborating, that if we have all this data, let's just start to think about some weathering. And I'm going to go quickly. We did in simple zircon aluminum or rubidium zircon, and there are changes and stuff. But then we moved into CIA values, very, very powerful. And we presented this last year at Goldschmidt together that if for 10 to 15 million years total, there are 5 events here. I'm talking about 5 different stages of black shales. If I put the line of median value for the CIA, how is this 60%? It doesn't, you could have these ranges, but it is mean value is 60%. So either the river has to be really big and or the penny plain where it's draining from has to be big. So now it puts the question of context that we could challenge fundamental ideas of sedimentology or other ways challenge like where is these nutrients coming from for these millions of years during Devonian time that bringing the basin so prolific, that's another question, and then making this organic plume, what I'm showing here, just go back, these are like paleo plumes that we haven't seen before, right? We see this today in the Amazon, Peru, and some of the coastlines that organic carbon burial, you can see the density changes, but we haven't seen this in the paleo world. But here is the thing. This data is available since 2011. Why haven't the students looking at it? Because you are not trying to see it in a different angle. You're just grading it on the surface, where is my high TOC, so I can find more oil. Forget the oil, because we are doing research, find the process or think about the process, and the data will follow. Not follow the data to fit into a process, right? So it's very, fascinating yet challenging to work in these environments. So I'm going to quickly shift this. So then this map is, again, public domain data. This is the soil data from USGS. and this kind of, Akshay and I kind of changed our game is that, Devonian Carboniferous boundary I'm talking about, you are seeing some papers on lithium isotope where they are saying, enhanced weathering. Okay, great. Lithium isotope goes negative, brilliant data set. But now I see the present day. This will be 0 MA, right, today. All the river catchments, we're doing statistics on each of the catchments. If I go to east, southeast US, I should be seeing CIA index of 80 to 90. That's the color what I have put. Whereas if I go to like California or Baja California, it should be 30. But both are 0 MA. So CIA value depends on rheology, weather, what is it draining from. It depends on a lot of factors. Even, you are thinking this of the big scale. So one continent, it depends on different like watersheds. So how do we assume the global CIA was high just looking into one core, one section? So my whole approach for this Devonian or any other time period is that can we move away from this mindset? I am part of it. I have done those mistakes too. I have got good papers out of it. But I think for the next generation, it should be that one section, one core cannot tell the global story. Because even within the US itself, I cannot tell a single story. How could I tell a global story for the whole world what the weathering was happening? Because it depends on so many factors. So that said, I'm going to move a little bit because in 2020, I also worked as a secondee to a mining company, data science mining company. It's called Cobalt Metals in Berkeley. I was supposed to move for 2 years, and then COVID happened, so I just worked with them online. May not be the best experience, but in terms of like work ethics, because I work for a society, socialist country. Everybody's equal. I really feel good about that. So like me, a janitor, and the CEO will all have the same vacation. Why? Because we should all have the same time with our family. I love that thing. So it is very fair in many ways. But of course, everybody has their ups and downs. Everybody has their positives and negatives. But they were investing in green energy, or Equinor is very much into renewables and everything. So we wanted to see how battery minerals or how that is done, but use some of those technology or ideas, data science into our work stream. That's why I went for 2 years. I didn't really went. I worked with them for 2 years. But the fascinating part was I worked with several brilliant mines in the copper and nickel exploration mindset in a sedimentary copper hosted. So then see the transition for me is like, okay, I used to do structural geology when I was an undergrad or master's, moved into sequence stratigraphy, then hardcore geochemistry, black shales to oil migration, nothing to do with black shales, slowly shifted to black shales, quality of oil, paleoceanography, critical metals, and now we are starting into like battery minerals, and then slowly transition. But nobody is giving me these roles. I'm trying to find it and get more knowledge into it. That said, this is a great paper I saw a few years ago, how tectonics and minerals and tectonics play a role. And I personally worked in Zambia for a lot of those 2 years, like lots of soil data, really, really good soil data, not publicly available. Some of them are, great to like actually jump on it. You can do a lot of things with it. But again, being in the industry, what helped me was I wanted to see everything always in 3-dimensional. Like for example, this map on the left-hand side is a very interesting way. I saw like this is copper and this is a cobalt. Where is copper? There is no cobalt. Where is cobalt? There is no copper. And this is they said it's like a hill. So I put like, drainage, how if a rain happens, where the water will go. See, all the cobalt is on the rivers. But copper is on the top of the hill, so I tried to put it on a 3D, how it's been designed, how is the water being flown. It started to make sense that nothing is rocket science. Just play with it, have a visualization power. Visualization matters. I am not a good writer. People bitch about it. But I want to make good figures, because to me, one figure is 1,000 words. I focus on figures, I focus on science, but writing, yeah, sure, maybe Claude can do it for me. Just kidding. But anyway, that taught me a lot of stuff. But very quickly, it moved into this, ideas of like minerals and copper, but again, because I'm a trendology guy, I love what should I say, like minerals, time. I looked into like last 5-6 years, I've been led the most of the research for Equinor for lithium, and we need to have a good concept. So I built this cartoon and I named it like a simplified play concept, but the real idea was like dumb it down for the managers, right? Because I really put some really good figures, they will not understand it. So I really dumb it down. So what I dumb it down is like the flat line is Earth's surface, anything on the top is a hill, anything below is an ocean or a lake, and then I'm going to go to quickly, and I fundamentally divide it into hinterland, that means weathering, or hydrothermal, right? Then you could, you can skin the cat however you want to. You can have a fractured granite. You can use lithium or aluminum, those kind of proxies. You could have a, ignimbrite. You can have an oil and gas basin, like a foreland basin. You can have, but then you are starting to see lithium along with calcium, magnesium. Where the hell did the magnesium came from? Where the hell did the calcium came from? You can say it's like salts. What you have to have a brine, you have to have a salty environment. But then you go to the western US, for example, you have all these active tectonics. You have this calc-alkali magma or, alkali magma, whatever. You could have a deep-seated periodite, under trusted subduction, slab, whatever, But then you start to see different types of fluids can characterize different types of basin. The question is, how do we figure this out when, lithium is, hot topic, but tell you what, we spent 5 years giving proposals and fundings to students, postdocs, everything. But then, few of us build a business value in the industry. In our company, we made a box called lithium. Once that box is made, this is very much like US government today. Don't record this, but once that box is made, you are no one. Why? Because you found like oil or you found lithium. Now we don't need to do any more research. So all the research has been cut, right? But doesn't mean I stopped doing the research, because I have to, the curiosity goes on. So we are still working with students to figure it out or write grants along with, integrating tectonics, multi-proxy approach, Libs analysis for soils to figure it out fundamentally source to sink ideas for lithium. That's my kind of thing that I'm doing, but alongside I'm doing a lot of collaborations with others, and I'm going to skip this. And then also, like, since it's black shales, we should probably see a paper fairly soon that how is thermal maturity and black shales play a role. Black shales could be an untapped resource for lithium as well. And with that, look into data, look into multiple tectonic things, because they all kind of work together. Not only one thing is, works. Integrated projects are much better than thing. Last, that these are all the basins in the world. Choose one, go for it, ask for data, data exists, have creative ideas, and have fun. Okay? Thank you. I can take any questions.
Cool. Questions for Swapan?
Thank you. You mentioned mass extinctions, sea level rise, CO2 emissions, and you also mentioned, you talked about your personal search and a sense of guilt for working for fossil fuel industry. My question is, why are you still working for Equinor, and why don't you quit and start your own company if you're interested in renewable energy, for example?
Good question, because when I published the Nature paper 2 years ago, my own communications people asked me that, right? that does it really affect things? But remember, sometimes what you present and what you publish, not everything has to be set in stone. If you are smart enough, you know what the model I put. The picture that I put, it clearly says all these basins has potential to have low carbon emission oils. But without oil, I'm not saying this in a very good way or bad way, it's just a statement that the world is not ready yet without it, right? So you live close by? Where are you from? Hereby? You? Like, are you live close by? You're from here in Seattle? Okay. But most of the people doesn't take, the world is not designed to just cycling, right? So it needs energy. Like you are having a class, you have a laptop, it all depends on energy. But that said, myself, yes, and it's not that I have any guilt. I'm proud of what I do, but it's about like how you balance your priorities. So, I actually have opened a non-profit organization myself as of 2 months. So yes, I can do a lot of research myself. I don't have to depend on a company. But at the same time, remember this, that every research, and I wrote this to the science editor once, that every research has advanced because of an industry. Be that pharmaceutical, be that energy, be that agriculture, industry has to come forward to help. Don't take this as a bad way. It's always a good thing, there's always a bad thing. So there's it's a cultural difference sometimes, it's a priority difference sometimes, but we cannot have the icing and the cake. We can use what we need and bitch about something that we don't. So we have to be fair to everybody, and that's how I feel. But if I want to do research, I feel like I need to do something of my own that I'm doing. I opened the organization myself. Okay? Yes?
I have a loud enough voice that may not be that. So you can hear, yeah. So I used to work for the Black Satan too for 25 years, but I left in the 2000s when we were still slipping paper logs.
Yeah.
Things were not digitized. You've probably thought about the multiple layers of Devonian shale in the Appalachian Basin.
Yeah.
Yeah, I mean, that are now being fracked and used. But my question for you as an employee of Equinor is, does the company have any mining connections or ambitions for extracting these, some of them being critical minerals from black shales or coal ash or brines?
When I say lithium, the way I am involved, and I know I cannot, this is not a corporate talk. Again, I said this is not. So nothing to be representing Equinor, but any of these energy companies, which is like say BP, Exxon, ourselves, we are all into this DLE technology, so direct lithium extraction. It is all from the produced water, and we even, when 2018 we first pitched to the whole Equinor, we even has this tag called cash from trash, because you are actually throwing away the wastewater. In a way, we even took this beta filter and demonstrate that beta filter does all the gunk from your water and gives you clean water, right? So what if is actually a good thing? Say you are paying $6 per barrel to be wasted, to be trashed, but you are taking all the gunk out of it and making a commodity from it. So there is no mining, there is no, so that's why DOE for this combined JV that we did with Standard Lithium, DOE gave us $220 million to produce the lithium because it's a safer and sustainable business, because it's clean, because US is not letting, in Rhode Island, there's pegmatites, 1% lithium. You could just think about 1% from brine takes a long time, but 1% from a rock, I can just have it. But no, we cannot do that. Like Serbia, Rio Tinto has to shut down their Jadar deposit. People are very vigilant now. The whole world is vigilant now. So because I had this slide, I cannot show it. I made this slide. It was very simple, like hard rock, then brine, then salar, time, cost, labor, all of that. What is green? Like a traffic light. So brine is like safe because you're already producing something, and all the things that we are producing today in this JV, like joint venture, has no oil in it. It's just water wells. And so it's very clean in a way, so the whole world is moving that way. Yes, we will have less lithium than we will just break a rock, but it's safer, it's sustainable, it's cleaner. That's all I can tell you.
Yeah, I understand. Still, there's no energy transition without mining.
True, because, different topic.
That's not a criticism, as you put it. That's just a statement of fact.
Yeah.
And it hasn't been faced very well. But
I mean, if you ask me, can brine really solve the lithium problem? No. Yeah. So, but that's at least one step forward because, to answer the other questions, like we sometimes call this creaming curve. At one point, 100 years ago, we could only drill 100 meters. Today, we are doing 8.5 kilometers. And then more and when technology has advanced, things that were unreachable is reachable today. So if we don't start daily today, some companies like Exxon or us, no technologies will be advanced. So tomorrow there will be better technologies advancing because there is a market for it. And then maybe we'll have a better, quick and cost-efficient lithium or any other commodity for that matter. Lithium is just an example. I shouldn't talk about lithium, but it's saying, like when you ask, this is just a, mindset of people, and people has to come forward and help.
thank you.
Sure.
Awesome. I think we'll take one more question.
I know you just mentioned the lithium from like the waste product. I wonder if any other like waste products from the fracking process might. This isn't a well-formed question, but it just makes me think about like both like how it can also mitigate some of the other impacts from as much as possible for the wastewater and stuff like.
That's not part of my talk, right? So I didn't talk about daily technology or waste product or anything.
Oh no, I was just
And I
thinking
cannot
about the
talk
lithium
about that.
stuff.
And we are not involved with any of this. We are just very clean, very safe, very, whatever. Most of the companies I can tell you, which were like energy companies now, they will not touch hard rocks.
I guess I'm sorry, I'm just it's not well formed at all. I'm just, like any process is going to have like the thing you want and then like the byproducts and like minimizing those kind of the amount of byproduct and the amount of damage it can cause to other things, like other externalities and stuff is probably important, and I think is an important part of the transition.
Sure.
Sorry.
No, you're fine.
That's really cool. Okay, awesome. Let's thank Swapan again one more time.